Today we are going to talk about the function, you can say. So last couple of classes, you can say we have understand how we can write a function, what is the syntax, and how we can use it. So similarly, function also have some different option, you can say, like function. Today we are going to talk about this is the one function. Okay, this is the one function. Generally, whenever we have written this function, I am going to call from this is the main method. We are calling this function. Whatever the business logic we written here, and whatever the value returns, they are returning back to the call function. It is known as a normal function. Generally, we are writing the function, but sometimes my functions is can not called by the only main method. If the main method is called a function, might be some condition met, then our function can call itself idle. So such function known as a recursive function. That means it is the function 1 we retain, and within this function itself, this function can be called another function. Maybe this is a function 2. This can be called to function and return back to here. But sometimes this function also have an option to call itself again. This is known as a recursive function. Whenever a function call itself as a recursive function. So generally, we have this is the function 1, this is the function 1, this is the function 2, this is the function 2, and this is the function 3. In our function we can write, but generally this function can be called from the main method, whatever return this value. Might be this function can call this function and whatever value that is written here. Might be this function call not the third function, we call itself and return the value. So whenever this function f2 call itself, then you can say recursive function. After that, maybe this call to another function and again take the value. So this known as a normal function call, means one function can call another function. Main is a function, main function and main is a function. They can call a f1 function. F1 is a function, they can call f2 function. F2 is a function, they can call itself f2. That is known as a recursive function. And it might be f2 function can call to the f3 function as well as, and they return the value. So this is known as a function change. So one is the different kind of function, different new different function you can call it. But sometime our business say, hey, why I'm going to call another function, because the same business logic I want to repeat, you can say. So good example, whenever we are studying recursive function, the very good example in the case of, let's say I want to go to the calculate the factorial of the given number. Let's give you want to calculate the factorial of 10. So what is the factorial of 10? Generally we are doing the, hey, whatever the number to input number, just multiply with the input number 4. Means give 5 minus 1 4. The same things we are repeat the same function. Now we have a 4. Similarly, whatever the 4 multiply by again minus 1 3. Same kind of function I want to again execute. Similarly 3 multiply by 3 minus 1 2. So our notice our business logic is doing just multiplication, but same just minus 1. This is initially 5, then multiply by minus 1 4 multiply by minus 1 3 multiply by 3 minus multiply by 1 2. Similarly 2 multiply by minus 1. So what happened here, instead of writing this code in the for loop, we can achieve this factorial function using a recursive function. Okay, so it's clear, recursive function is a function they are calling itself. So let's write this code, how we can retain this logic inside a particular function, and this function call itself here. call itself here and call itself here. Question is that how many number of times the function call itself when they are going to stop. Let's I say, hey, this is my function, this is my function, this is line 1, line 2, line 3, call itself. They are going to the call again here this function. Again they are going to 1, line 2, line 3, and again they are calling. So notice this is going to infinite loop, never come out or the last line a return value, possible cases. So in a recursive function, this is a very catch point, critical point. You have to decide how many number of times we are going to the call recursive function. Your recursive function must be break after some condition after some times, because if you are not considering to stopping the recursive function call, this is a very you can say critical situation. You can say your application going to loop, and after couple of seconds it will going to out of memory, because whenever you call one function it will require the stack memory for that. Again you call another function, same function, another state created, after another call another state created. So after couple of invocation, notice whenever we call this function it required the stack memory. Again you call the function, they required a stack memory. Again call the function, this required a stack memory. So after couple of call, because our system have a limited memory, so our application going to throw, hey, out of memory exception. So a recursive function is easy, but please ensure that you are guarantee in your code, hey, after 2 call, 3 call, 10 call, 100 call, our function must be stopped. So in our case, like we have taken the example of factorial, calculated factorial of 5. That means we are calculating for 5, yes, for 4, yes, for 3, yes, for 2, yes, for 1, yes, for 0, 2 again, 1 multiplied by 0, it's become 0. So really we are not considering to multiply by 0 until your number is 1, it's okay. Before that, don't do. Something you have to ensure that you are going to put some condition, on which condition your recursive function call. If condition fail, they do not call. Okay, let's look at the codes. So here I am going to write one function, let's say factorial. Okay, this is the factorial of your number. You say a number int. Okay. So notice if I call this function, hey, let's call, and this function we have to return value as well as, okay, they have to return. So let's return, and here, so whatever we pass, whatever returning, hey, for factorial pass let's 5, and this function return the factorial. Okay, and dot print. Okay, factor of 5 L of that's number just 5 equal to comma. Okay, so what happened here? You just simple function, this is not factor, this is function, you are just calling the and returning this. Okay, and that's run. So here we are simply calling this factorial function passing number, and you are getting the same value whatever you want. But here our objective is not just return the same value, just calculate something. Can we, this is the main function calling the factorial function. It is possible factorial function can call another same factorial function, that become a recursive. Okay, so somehow saving and something they are still. Okay, so let's code. Okay, so here what I'm saying, say, so this function, how to calculate factorial of whatever the number we have, say, hey, not true. No, notice we call factorial of same number. Okay, good. So here now next question, how we can write if you call the same function. Let's see here, maybe this is the factorial. Let's say you say whatever the factorial I calculated, okay, whatever the factorial I calculated, whatever the number, hey, let's fact. So first we have to always think our, instead of writing code, we have to think when I have to stop calculating factorial. Whenever our input number, if our input number like n, whatever the input number is less than or 1, okay, so less than 2, you can say, whenever 2 less than 2, it will return the same number. Maybe you can say, hey, return the same number, because we are already calculated, because number less than 2 means 1, factorial of 1 is the 1, factorial of 1 is the 1 is the only one. You cannot say 1 multiplied by 0 become a 0. No. So here say, hey, this is the, if our number, whatever the number we have, number less than 2, then return the same. So this is our breakpoint, and else not, then what you return, whatever the number, and multiply by whatever the factorial, whatever the call factorial of number minus 2. Okay, so in this way, notice here, if number less than 2, then you are just returning the same number. Else, you know, I have going to calculate number, again call the whatever the factorial of this. So what this code say, notice here, from this function we are calling the same function. So this is known as your factorial function. Notice here, this is the function body, this is the function body. In this function body, I am going to check, apply one break condition, the break condition, and after that I am calling the same function here, just pushing the number minus 1. So how it works, let's see, I pass here 5. The first time this stack come, one stack created for here, input n number become a 5, you check 5 less than 2, no, go here, return what, n 5 multiply by what, again call the function, means here waiting for another function call. This function call for what, this function call whatever the n minus 1, this is the 4, so we are receiving input as a 4, so check 4 less than 2, no, go again call whatever the 4 multiply by, again call another function, what function, 4 minus 1, this will become a 3. Okay, now again check 3 less than 2, no, so go again return 3 multiply by what number minus 2, 2, again call function, no, here again call another function, no, here call for the 2, again call another function. Okay, here say 2 less than 2, 2 less than 2, false. So what's a return? Let's return the 2 only. These return the 2. Come back here, it's a 2. The 3 2s are 6. Now this 6 return back to the here. 6 4s are again whatever the value return, again return here. And finally they return your out. So whatever the recursive function call, the similar function, they are going to the nest, they are going to the nest, they are going to the nest. Once this return value, they return again back to where? They return back, and finally we calculated exact value. Look like this become your 5 multiplied by 4 multiplied by 3 multiplied by 2. Yes, because here we are stopping less than 2. If you want to multiply by 1 as well as, because notice in multiplication you can multiply any number with 1, you are getting the same value. So I am writing here 2. Some maybe write 1. Okay. So here maybe you can write, hey, this is the 1 less than 1. That means they are only considered less than 1 means 2, then it's return a 2. So here you can write here the function, maybe just for your sake. How many number of this function called fmt dot println and your n equal to your n number. Okay, this is number, and even you can say hey, here you can say call factorial n star multiply by and n minus 1. So here say whatever the n multiply by n minus 1. So this value we are going to the calling. So whatever the here n, and here even say just call the function factorial function instead of this. Just for cut here you can mention here this fact, and here mention this. Okay, so here you can say comma n comma, okay, and similarly here say comma n comma. Okay, so simply say in this way, just look like no here. And this what say here, right. So in this way, just ensuring that we are doing our logging just for the way our code is works. And let's again test this. So the number of times we call, number of function, and again returning back. Even you can say this result you can assign a variable. So here just for logging purpose, let's keep our fact equal to whatever the we receive value in this factorial, and again calculated here, and then return. Here say return what? Return f comma f. So here you can returning whatever the value. Here you call them, after calling whatever the value return here, and whatever the n you can just multiply by. Even you can write the different way. Even you can write the first line and test what is the value. As of now, let's keep call and multiply by fact this call. Okay, let's run the output and check the what we are able to understand this code or not. But okay, we miss return. We have to return this return f. Okay, again run it. So here what we are doing, we whatever we have input, we are checking condition. If input is less than 1, just return the same number, else we are calling this factorial number, whatever the value returns, and then here always we have to return, and even it would be good. What is okay? So let's write this code using here one function call take call return value. Okay, whatever the return value we have, call instead of let's simplest, not an issue. Run just nothing problem. It will this time just I want to show output how this recursive function. You can just maybe like in the separate line and check what is the output, and then just I'm saying once you return whatever the factorial we have calculated here and then return. Okay, sometime what say why we are not running, it will run. So in parallel you can say even until this code is not running. So it's clear what we did in this code just now. Notice here we finally got the output. So notice here first we have number 5, then we call for factorial field. We notice, and in first 5 again going to the call 5 for 4, and again function the same. This is the one function 1. Okay, input for 4, and again call for the input for the 4. This again call the input for the 3, again call the call input for the 2, and again call input for the 1. So problem because here we are calling less than 2. This is the problem, that will become a 0, and 0 multiply with return the 0, again 0 go back here, 0 back here, 0 back here, 0 back here, and you are getting the all the 0. So as say here we have to say hey no till 2 because 0 is the multiply everything. So and some logging best would be best can be. So here instead of this this is the okay less than 2. This code instead of calling this here say hey here just and less than 2 return and less than 2. Whenever n less than 2 return n. This is the only one time, and after that you can hey call this function, call this function. This is the your r whatever the value returns. Okay, this is the function, and you can say call function, and after that you multiply by your return. Here say whatever the call this function and return what the return value comma r, what are the what their returning value. So you call this function You call this function, and whatever the function, calling for n minus 1 and getting the return. Whatever the return, you again just multiply by n multiply by returns. After that, you are maybe here. You can simply say here, and just this is the n, whatever the call here. Okay, just you call this factorial, whatever the return are, just multiply by the, and then comma. You can say whatever the number n multiply by your here and multiply by your r result. So here say, how's that? N multiply by r equal to comma, and this is your factorial. You can just write here. Okay, this is already you have printed whatever the number n. So let's print n comma n equal to. So whatever your number you have, then call function, return value r, again n minus r multiply, get the result. Finally you are returning the result. Okay, so this is the way. Just for the logging purpose, I write different of this. You can write the same line. Just I want to ensure that this is the call, and just, and here you can say call. Here you can say call function, call, and here you can say return. So this is the just not possible for here. Okay, so here we just calling the function, and here after that call we get the return value, whatever the return, and that's calculated. Okay, so let's check. So somehow why I am writing this log something. So whatever the concept we are say, like whenever a recursive function call, hey, one function call here for the given input, whatever the input, they have call another same function. So different, you can say, stack created for this. Same function call the same, different stack created for this. A different input. Whenever again call, different stack frame created. And whatever the value return, they again go to the back here. Again return go to the back here. Again return go to the back here. And finally they return to the main. So in this way, chain calling function and returning function happen in the recursive call. So let's observe the output. Notice here. So okay, this is a new call. Okay, what is saying 5, 4, 3, 2, 1? Why they are calling for the 0? What is the wrong? Okay, this is no, somehow this is the old. I think this is the old output, because here not written n equal to 4. This is the no log. This should become somehow, right? The old logic somehow, yes, still run going on. Yeah, it's still running going on. I'm confused because this is the old log over, right? Old log, because you don't want to calculate for 0. I want to only calculate till 1. Okay, because whenever you are calculating 0, you are getting all the 0 value. Okay. So any you can say the programming language. Now it's come. Notice here. Here you getting the n equal to 2. So something we miss. So here notice first we call for the 5, or we call 5. Okay. So this is the for 5 call, and this is the return value 24. But question is that we are not able to demonstrate hey, this is the call for 4. We are exact value, but before that I was add just one logger. So this is the just return calls, return call. Finally we are getting the, whenever we return 1, this called to multiply by, this is the n multiply by your 2, you are getting the result 6. This is as expected. This is a like your 5 multiply by 4 multiply by 2 3 multiply by 2 multiply by 1. Okay, so here notice that this is called 2 and multiply by 1, 2 multiply by with 1. Here again this, again this, again this, again this. So let's now add one more line here. So here one more line here, just call, okay, call for n, just here return, okay, just here a return. This is this method have a 2 place return from here or from here. Here you have to say comma this now something wrong. So here say I want this should be not print the value, this is the equal to, okay, and here say whatever the this comma, okay, comma this comma, okay. So in this way we are printing. So whatever the value we receive, this is the n and this is the n multiply by r, whatever the value. Okay, so here just same thing, just for the explanation how it's work. Code is the same, you can write the similar code is the same like whatever you have, but it's just for the explanation how your code should behave. So output is the as per expected. Okay, you are calling for function 5, then 3, then 2, then 1, returning back, return 1, multiply by 2, they return 2, then 6, then 24, then multiply by 5 is equal to 125. So here objective is that many code places you are going to make a recursive call. Why? Because the similar kind of code, hey, same kind of, this is a small logic, but sometimes this is a bigger logic, and you want to calculate this logic for a specific A input, and the same business logic you want to calculate for the B input, maybe C input, maybe different input. So instead of going to call this you can say the for loop, we have one option you can do using this recursive. Last call you can, whenever we are studying the for loop, the same code we can return in the for loop as well as this. The only objective here, this recursive calls make our code is some concise, some is small, okay, and that easily understand you can say. But sometime whenever you're going to debug the code and try to understand, explain call flow, we have a sometimes complex, and this is the recursive function also have a one of a disadvantage. This can be, notice here function call for 5, okay, then for 2, then for 3, then for 1, and whenever you call 1, returning 1. So here return 1. So what return? 1. Then you can say, hey, this input called 2 and they return value 2, 2 multiplied by 1 is 2. So whatever this return 3, return 2 and input here 3, you can say 3 multiplied by 2. So in this way you can reserve, hey, this finally return 1. So you have a, because calling function 2, so 2 multiplied by 1 return the whatever 2 output here return, okay, and here 3 multiplied by 2 what return? 6. 4 multiplied by 6 what return? 24. 24 multiplied by what return? Output is 1. So in this way you can get the same output what you expected, okay. But this is first notice for here, notice here input call for 5 here and return value for here. Okay. Similarly, first time you call for 5. This is a 5 call. What is the return value? Return value is the 120. This is the call for 5. Similarly, this is the 4. This is the 4. What value return here? This is a call for 4. This is the return. Similarly, call for 3. This is the call for 3. This is the call for your 2. Okay. So this call to call the factorial function and wait for return. Once the return value calculated, then return back to the here. Then return back to the here. Then return back to the. In this way, recursive call get the complete. Okay. So even this complete code, just for the sake of understanding, this complete code, just comment out and you can simply write, hey, just this logic, if n less than 2, then return whatever the n, and else return whatever the n, multiply by same function and n minus 1. Okay. So this is your actual logic code, but just for explanation we are writing this couple of. This is the only. Here simply check number less than 2, just return same as call the same recursive function, and you are getting the same output as expected the previous. Okay. So this is for your you can say recursive call. And one thing, sometime please ensure that you have to make sure your recursive function is not going to infinite. Okay. If you not put the condition, this will become a messier code. Maybe your server is stopped, you are facing out of memory exception, right? Please ensure that. Okay. So notice here I am getting the same output which are previously getting. That's good. So let's talk one more point. But here similar kind of you can have function, many functions you can call. Maybe notice here factorial function, we are calling it a name factorial function, and what are the business logic we get it. Even you can call maybe a recursive function, maybe anonymous function without giving any kind of call, you can say. Okay. So many places sometime you have to call like anonymous function as well as. Okay. So let's look. So sometime you know, okay, what are the anonymous function? Here I am giving the name of function, okay, explicitly. Separate function I written and calling this function. It is a good. But sometime you will find the code where you have a just like a function. Let's see, we have a function. We have a function that take maybe take function. Okay, this is a function. This directly we are not writing in a function. Take input variable maybe number n. Okay, okay, and they return your integer. Okay, and you are writing the code. Okay, so here you are writing a function. Notice here I am writing the function, but I am given the name. But sometime you can write a function without name. So question, how I can call them, how I can use them. So here you can say, like here you calling the function and return this value here. So this complete function can be one value. Here say, hey, maybe this is a kind of a, you can say Fibonacci series function. Fibonacci series function, right? In this way, you can let's see here. So you can say, instead of just you declare, hey, this is the variable, that is the variable name Fibonacci, but what is the value? This is not integer, this is not float. You can say, hey, this is the int, this is the int value, but I am going to say, hey, this variable can be a function. The function, so what is the function syntax and semantic? You can say function. hey, this is the function, this is the function, this will take an integer and return integer. So this is the way you can say, hey, this is the Fibonacci, this is a variable that can hold as a function. And we can give here, you can name as also variable. Okay, but question is that this is the variable of function. So what is the function logic? Where the function defined? Because so here you can say, hey, this is the my Fibonacci variable, and I am say this is the my function, this is the my function. I am going to giving the definition here. So here notice I am writing a function, but this function don't have any name. Just this function can be initialized variable, or even you can directly say, hey, okay. Here you can write whatever the business logic you write. Hey, let's I say if our number less than 2, then simply return your number. Okay, and if not, then return maybe same function, whatever the Fibonacci function call, just like a similar word, n-2 plus Fibonacci FIV n-1. Okay, so in this way you are writing your function. Okay, so here we are writing a function that is the recursive function, because this function is called same function again here. Same function, right? This is the variable name. This function called same function called. So sometime you are going to write a function that may be anonymous function, but this can be recursive because you are using this variable name, variable holder, and calling this function. Same variable, or you can use for the access them. So let's say I want to call this, hey, this is the variable, this is the variable, and this variable I can call for the number 7, and whatever the output, okay, you can say, okay, output, okay, yeah, okay. Output. Okay, so in this way, this is the logic of the function, is that recursive function not only for the actual main function, even you can write recursive function for your anonymous function. The function they does not have a specific name, but whatever the business logic you assign in the variable, that variable become a name of this function. Okay, so in this way you can sometimes you write the function as a recursive function, but without giving any name. So what is the function name? The variable where you can assign it. Okay, so couple of places you can say, like recursive function help us to make our code concise, and it will you can say just save our time instead of manually bigger for loop or splitting code in the multiple part. So it's help us. Okay, so let's it will compile and give the output. So here the logic is that you can write even your recursive function with your normal function call itself, or even any anonymous function which don't have a name. Still you make a recursive call with the help of the variable where you are going to return in this. Okay, here you mention this is the function and this is the return value, it's the input. Okay, okay, so hope it will compile and give the output. Yes, still compile, my compile, yeah, Notice here output of the whatever the I am passing here number 7. Here I am passing 7. So let's check verify output. So here you pass the number 7. 7 is less than 2. No. Here go. What say? 7 no key up 6. Oh, somehow this minus 2 and this minus 1. Okay, sorry. A Fibonacci series is the like a number. We say, hey, we have a 2 number 0 plus 1. What is the output? Become a 3 plus this become a 1. So now this become a 1 and again 1. 1 plus 1, it's become a 2. Again 2 plus 1, 2 plus 1 become a 3. Again 3 plus 2 become a 5. Again 5 plus 3 become a 8. In this way, means notice whatever the 2 number, if this is the 2 minus a previous number, they are going to just minus it. So in this way we can calculate a Fibonacci number like minus 2 and then minus 1, and whatever the value we are getting a plus, right? So in this way, so it will calculate the output same whatever you are expecting, right? So good. So let's one more thing today I am going to talk about that. This is the your function whenever one function call itself or recursive, or maybe a function, anonymous function also become a recursive with the help of your variable name where your function initialize. Here I am declaring, hey, this is a variable, this is the types of function. That means they can hold the function. And where is the function? This is the anonymous function. Hey, this is the I am written the function. There have no any specific name, but this is my business logic. Whatever written, I am again assigning to this variable. This variable become a function. Now this you can call from the main method. Right? Okay. So today let's talk one more thing, and then we wrap up this class. Like whenever you are calling a function, because this is the function, this is the one function, okay, and I'm calling this, passing this value, and they return. So here let's I just now just I comment out, okay, comment out, and here say, hey, I have a, let's say, another function maybe increment value, INC increment value. Increment. This is the increment. We receive the number, okay, and here say, hey, whatever the number we have just change the number. Okay, change. Okay, change. This whatever the value they have, hey, let's assign to maybe 0 or 1 or 2, whatever the number you want to change. Here you can, this is the one function. So here from a main function, like I call change. So here I let's declare one variable value equal to 5, okay, and here I pass the value, okay, and so here just print fmt dot println v equal to comma v, okay. So this is the v, and after this, so what happened here, v equal to 5, I pass this value here, change function say, hey, we receive n, I change to the 0, and then return. This is the one, okay. So whenever you are doing this activities, so notice let's also here say, let's value of v, just for confusion, okay. This also say this is the v. So what do you think? If you run this code, hey, here print the 5, call the value v, this change v to 0, then what the output would be? So let's run and check. So here this is the I'm trying to say, whenever you are passing value from here to here, what is the, you can say, scope or which value where someone can access. Okay, so any variable that declare within a block, you can say, hey, this is the one function. Okay, and I am declare any variable here, okay, this is only visible inside this. Okay, and if I am another function variable, I am say, hey, call this function with a specific value call here, and here we receive the value. If I am doing any changes here, like here making 0, so this will not impact anything on here. Why? Because here, whatever the value of here, I am just copying this value variable to the here, and here they have also become a local copy of this. And if you are doing any changes, it will only impact on your local changes. Where is output? Okay, not running. Run. So here my objective is that sometimes this value don't understand can be changed here. Why? Notice here I am getting the 5 and 5 here. We are not doing any kind of a change. Notice here look like we are changing. Here look like we are changing the value, but here same value we are reflecting. Why? Because notice here two functions. This is the main function. This is your main function. This is your main function. Main function I have one variable. Yes, this is my variable. This is my variable b. I have a value 5. This is the 5 in this text. This is the 5. This is the variable we are referring. Okay, good. And here's a print 5. They print in the 5. Change the value. Change means we are calling the change function. Means another variable they are created, and they have a own variable v, another variable v. Oh, this is another variable v, What is the value here? Here sending you. What is the value here passing? I am passing the 5. So this value 5 copy in the place of a local variable b. Okay. So this till now here v is equal to 5, and here say, hey, v is equal to 5. I say v equal to 0. So here say, hey, v equal to 0. This means this variable going to become a 0. Okay, and this function return here. Again say print v. So I am printing this v, my local value. I am getting the 5. So please note that whenever you copy any passing any value, this is simply copy the value, whatever the value of this variable, to the local copy of this change. This is the change function. This is the main function. Main function have a variable, but this value is not changed by this change function. The change function cannot access this v, They have a own variable. If you here print like a value of, if here print value of, this is like a main, okay, main function. This is your change value function. So this is the local copy of this. Means this stack have own variable of v. This main have own variable of v. This can only change and reflect anything on his variable, and this change function only can change in its own variable. So please, this is the scope of you can say any method. So whenever you declare any function, function 1, function 2, any function, each function required one is stack frame, means one memory space where every variables are they are going to store. And any variable that this variable declare, here they can use them, here they can change them, here they can whatever they want to clean up. But this variable, whatever the variable we are storing, this main method, this variable is not accessible by any different method like a change. Change have a own copy, own different variable, you can say, own stacks, own memory, own have a value, and it can whatever the value pass here as in 5 value, they are just copying in local variable. So this is the But sometime in our application, I want, notice here, a main function value 5. No, main value 5. Change value also this is 5. But after change value become a 0. You go to the main value, again you find the same value because this value is not changed by your. So, but sometime I want maybe this is my main function and this is my another function. I want whatever the variable they have this variable value. I want this can be changed by both one. Sometime needed. So the default behavior for this is they are not accessible. But if you want, how you can they? So that is the concept help us the pointer. Okay. So pointer help us, hey, any variable declare inside a particular main method or a method or b method, this variable value I want some other method, some other function can also change, can also read, can also update. Then we have to take the help of pointer. So what is the pointer? Pointer is just nothing, just like one variable like n is the integer type variable. They are holding the integer value. Similarly, any variable, if the pointer type, they can hold the addresses. What do you mean? Here, whenever declare v equal to 5, the v is the placeholder and the value are placed here 5. And whenever I call this function, I don't want to pass this 5 value. I don't want to pass 5 value here. I say no, I am going to give the address of this 5. What is the address of this 5? Just use the ampersand operation. So they return the address. So I pass, hey, what? Let's see address of this is the 1000 is the address, right? So I pass, hey, you receive the address is the 11005. Okay, this is a, okay. Say okay, I can have address. In this address, I can go and change the value whatever I want to 0, 1, 2, 3, 4. And once this method complete, after that you come, hey, read this value. Might be you notice the value is changed, volume or divide. So some scenarios, some cases where you want the particular variable, particular value can be shareable, can be accessed in the different function call, then pointer help us. So what is the pointer? Say, hey, pointer is the variable, pointer is the variable, they can hold the address of another variable. Oh, this is the integer value. What is the address of this? They can storing the address of the variable. How to know the address of the variable? Using the ampersand operator. This operator help us to find out the address of any variable. If the variable is integer, the variable of integer, you can say address of variable, they return the address of integer. So similarly, address of float, string, char, anything, so you can use the address. So here for pointer, you are using the symbol star note, hey, star p. That means this is the pointer variable of p types integer type. Okay. So they can hold only the addresses. If you have an address of this, you can change the value. You can say whatever the address, hey, address of p can change the value 0 or change the value 3. You can do. So let's write another function here, similar function. Let's I write another function. Hey, another function, the shared change, shared value, share value via addresses. So here you can write function is okay, and here say, hey, this is the look like our star. This is the syntax symbol. Here you can mention, hey, this is the your star variable. Just you mention here star. The star means how compiler indicate, hey, this is the pointer variable. Okay, so whenever say star, this is the pointer variable. Okay, and you can say, hey, I want to print the value. I want to, so here you can say print the value, or you can say comma star v. So this is the value. So whenever you say star v, this is the value. Here v actually addresses. V is the addresses, and apply the pointer, you get the value. If you want to change the value, you can say, hey, star. Star means accessing the value of the given pointer. Okay, here notice that in our scenario, this is the variable v, and whenever say, hey, this is the variable v, and this is the pointer variable, means they are holding the this is your main, this is the main function, this is your change function. The change function also have a local variable v. Okay, local variable v, but here main function have a v variable which hold the value 5. Okay, but here in the shared change variable, this is the value v, they have own variable v, but they are holding the addresses. This is not 5 value. Previously they are holding the 5 value. Now they store the addresses. What is the address of maybe? Address of maybe x 00000 hexadecimal. This hold the x000. So here if you print the v, they print this hexadecimal number. Here say no, I want to value. So whatever the value, so they go here and find out this address value 5. They print the 5. So here say, hey, star v is equal to 0. Okay, v means this is the address I have. Go to the particular value. This is the value. Change value 0. Change value 0. So let's call this function. Okay, so here I call another same. So here I can say another value. Okay, another value is equal to, let's say, 5. Okay. Another, this is the another value, just for reference, another value. Here instead I'm going to call this shared value, this function. Okay, and here notice here this is the variable of integer by default, because the value is integer, and here I am going to say, hey, in pointer, that means here you have to pass the addresses. Address means m%. So whenever you are passing m%, this means we are receiving the address. So this is the only, this is the address, give the address a value, this is the variable of this. So you can find the address of another variable v and pass here, we receive the variable and change value, and after that you can change value. So this is the major you can say concept between your pointer. Pointer is nothing, just is the one way where a programmer can read any value or change the value, read the value or change the value with the help of addresses, not the actual. And if you really want to find the addresses, then you can use this address operator. If you want to actual value, then you can say star the pointer. So whenever say star pointer, this means we are going to actually reading the value of that. You can say only p, that means only reading the addresses of this, address of this. So only this is the be clear. Notice here our previous example, like this is the one variable v in the main function. This is the main function, you can say this is the main function. I have a v variable value 5, okay, 5, and call another function, change function. I call change function. Change function also have a whatever the value v, here you copy the value of v is equal to 5. And if I print in the value v, here you can reprint the 5. Change the value, just change the local copy 0. and here printing the 0, here 0. Okay, and after that again call finish. Here I printing again value v5. I still 5. This okay. Now the second scenario, another way, I create another variable. This is another variable v, initial value 5, initial value 5. Here say call to the function. Here I am another function. I have a pointer variable, okay, for v. Okay, so whatever the here by for passing the address, what is the address of this? Some hexadecimal number. So notice this value pass here hexadecimal number. The first value you are printing to hexadecimal number. But what is the value of this? Then print the 5. I change the value, and then go to the main method. Here I can go and change the value is equal to 0. And once method return, I print the in the main function, I print this value, I am getting the 0. So in this scenario, notice here, just change the value. So here you have printing the two value v and v star. So notice here they printing the complete address. V means complete address. This is the address. A pointer v means the actual value. Okay. Here say change the value to 0. So it's become a 0. And it's become a 0 in this method to read the value of this, and even in this method as well as I am getting the value of a 0. Okay. So this is the concept of your pointer and address. Many places in coming classes, or you can see in your application, pointer help us to sharing the data or value between across the function. This is the function 1, this is the function 2, this is the function 3, the function 4. If we have this is the variable v and this is the address using this, a value using the pointer. And if you can pass the address to any variable can change read value from your set. You can say pointer help us across the function, you can share the value. One function can change the variable or value of another function. Without pointer, no. Without pointer, this variable is only accessed by this variable is only accessed by this one private copy, you can say. The default, all the variable declarations are generally for the local, means each function have a own copy and only those functions can read and update and modify it. And other function, they cannot, this function, another function cannot read the value of another function. Okay, so here same example, another value is the 5. Go to this function, what is the value? This is the value, address, and this is the pointer. And after I changing, we change the value 0. And similarly in the main function, also notice this value will change. Notice the same address here, even you can print them. So notice here we have copied the addresses. So here this method help us to take the address of this variable. Okay, and even you want to print address of this variable, you can also print here comma. This is the address. Okay, so whatever the address, here I am passing the address. So whenever this function go, this function also this is the v, and you can say this is the value, and you can say star v. Okay. So if you print only v, you can get the actual value. If you want to star v, then you can the actual value. Before after change. So before you are getting this same address, and pointer means actual value. Here the same address, whatever this variable have, how to know this variable address? Using the same address you are copying in this value. This value you can change. So this is a very you can say good understanding that we should understand pointer and address, because many places in your code you find that these are the use. So you should clear whenever you declare any variable, like any variable something, okay, whatever variable, like, and before is data type like integer, and you say star, this indicate this is the variable going to store as a pointer variable. And whenever you're passing this value, you can pass the address operator used to get the addresses. Someone want to change the value, you can use again pointer variable. To reading or writing the value, you can use this pointer. The pointer is the two places you are going to use. One, while declaring the variable using the pointer, means indicating this variable v is the pointer types of variable, but this variable hold only addresses. On those addresses you want to read the actual value or update or modified, then again use the star value. Okay, so notice here in the main function, notice this is the same address, and when we run the before, this is the my value is the address, pointer v means the value, and after changing, address become the same and change the value. And after in the main function, you notice I am getting another value of a 0, because this is the same address which have a main function are going to be changed. So this is the main, you can say, concept of the pointer. Means any, not only main, any function, this is the main function, any you can declare any variable. By default this variable have a two things. One is the memory address, like this one, memory address, and actual value, say hey it is a 5, the actual is a value. So value is the actual value, and the container holder where this value are placed, that is known as an address. So generally in the computer our address is the hexadecimal number. Whenever you run program, each times you are getting different hexadecimal, right? And so here, how to find the address? You can use the address operator. How can change receive this value in the different class using this pointer. Okay. So whenever you want to declare, this is the variable v, this is the types of integer. Okay, how can declare variable hold the addresses? This is the variable and this is the pointer, and you can say this is the integer. That means this is the pointer variable, they are holding the address. This is the normal variable, they are holding the values. Okay, and from this variable, if you this is the p variable, pointer p. If you use only p variable, p anywhere place, please, p means the address of the particular variable. And whenever you say hey star p means you are going to read or write the value at this address. Okay, so these are the some basic concepts where today we discuss like the pointer. So be clear, whenever you want to declare any variable as a pointer, just mention this, the declaration of variable is the variable v pointer types. What the value can hold? They hold the address of any other value. How to find the address? Ampersand operator. And here if you print only v, print the address. If you print the star v, that means value. Here I am reading the value. Here I am the reading the value. Here I am writing the value. Hey, whatever the v, go and change this value to this. Maybe 5, maybe 10, maybe 15, whatever you want. So this is the basic concept, and many places we are going to use this pointer. The pointer variable help us to change the value of a variable that is declared in another function. Okay, this is this function, and this is this function, this is this function. If this function declares some variable, this variable value previously without pointer, only this function can read and change. Okay, this function cannot read this function cannot read this. Okay, but pointer variable can change, pointer variable can read, can modify, because this function share the addresses. So now this variable also know, hey, this is the address, I am going to this address and change the value. If this not giving to the address, you cannot find where this value and how I can change it. Okay, so let's do couple of example practice to understand pointer, address, and pointer help us to share the address of my variable, and whoever function going to receive the address, they can full control to read, modify, change the value. And we've also discussed a function with the recursive, a function called the same function. Maybe recursive function can be anonymous, a function can without name, you can also say, hey, this is a recursive function. So let's try this couple of examples, and might be this information to helping you. Thank you for watching this video.